The second lesson is volume and surface area, which is also a review from grade 10. So I'd like you to go through this, write down formulas you think you need. You may need some, you may not need others. I think for volume of a prism, my advice to you is use the formula volume is base times the height. It's the area of the base. So, if this was the area of the base, you would just multiply it by how high it is. Okay? If you look at a different shape, you would find the area of one of the bases, say this base, and then multiply it by how tall it is. Again, I think that's the easiest way to calculate volume. Okay, so for surface area, what I would do is I would just draw each face and find the area of each face. Okay, if you remember, the volume of pyramids is just the same as the volume of the prism. You just divide by 3. So how would you find the volume of a triangular prism, for example, this shape? Okay, you would find the area of the base, multiply it by how tall it is, and then because it has a point on the top, because it's a pyramid, you're going to divide by 3. That goes for all pyramids. Okay, so here are a few special shapes. Maybe these are the formulas that you might want to remember. Maybe put them on your cheat sheet, but they are review. Okay, so let's try a few questions. Given the diagram, find the surface area of the tank, find the volume of the tank. Okay, the surface area of this tank. This surface area is going to be the surface area of the cylinder plus the surface area of the cone. Okay, but remember that we're not going to count this circle here that overlaps. Okay, so what is the surface area of a cylinder? It's 2 pi r h plus 2 pi r squared. Okay, let me just write this cone part over a bit further. Okay, so do we need all of this for the cylinder? What part is this? That's the sides of the cylinder. Okay, and what's this? Those are the 2 circles, the top and the bottom of the cylinder. Okay, so all I'm going to do is I'm going to say I don't need 2 of them. I just need 1. Okay, and I'm going to say because of the overlap. I don't want to include, again, I'm shading it in here, I don't want to include this circle. Okay, so the cylinder is going to be 2 times pi times 2.3 times 5.2 plus pi times the radius squared. And then I'm going to add the cone. What is the surface area of a cone? So the surface area of a cone is pi r squared plus pi r L. Pi r squared plus pi r. Now I think last year, grade 10, you used S. That formula there has an L. I'm going to put S, and just to remind you what that is, that's the slant height. Okay. So looking at this formula, this is the surface area of the cone. Can you see that I don't need pi r squared? That's, again, that's the circle here on the bottom of the cone that I don't need. So all I want to do is add pi rs. Okay, and that's pi r is 2.3 and the slant height is 3.1. Okay, so now we can just put that all in our calculator. Okay, and if I put that all in, I believe I get 114. I'll write the whole thing here, but I think I can say 114 meters squared. Okay, then let's do the volume. the volume is actually easier. So we'll take the volume of the cylinder plus the volume of the cone. So volume of the cylinder is pi r squared h, and the volume of the cylinder is, volume of the cone. Okay, it's pi r squared h divided by 3. Remember, that's the same as the cylinder, but because it goes to a point, we divide it by 3. Okay, so pi, and by the way, with volume, you don't have to worry about overlap. You just add the two shapes together. So we're going to have pi times 2.3 squared times 5.2 plus pi times 2.3 squared times h, which is 3.1 divided by 3. Uh-oh. 3.1, that's not clear. I suppose this is the height and not the slant height. We need to go back and change this. Okay, let's just finish off this question and then we'll go back there. So we have pi times 2.3 squared times 5.2 plus pi times 2.3 squared times 3.1 divided by 3. Enter. So this is 103 point, I'm going to round off right away, 103.6 meters cubed. Okay, sorry about this. So here's our cone, and it tells us that the height is 3.1. And you know that the radius is 2.3. Well, if you look at that shape, this allows us to use Pythagoras to calculate this distance. So we're going to have 2.3 squared plus 3.1 squared is x squared. So x turns out to be 3.86. So that's the number we have to put there. So that's going to change our answer here a little bit. So this turns out to be 119 point 119.656981. So we'll round that off to 119.7. Okay. Example 2, if the farmer wanted to fill up the tank from example 4 with fertilizer, which is sold in cubic yards, how much fertilizer would he need to order? Okay, so this is a volume question. Cubic yards, volume. We know that the volume of this shape is 103.6 meters cubed. We're supposed to change this to yards cubed. So we need to have that ratio. Okay, because we know 103.6 meters cubed. I want to know how many yards cubed this is. Okay, so let's go back to our original conversion table. And let's see what it says for yards to meters. Okay, do we have that here? Yards to meters, right here. It says 1 meter is 1.0936 yards. 1.0936. So 1 meter cubed is 1.0936. Was that what it was? That's yards cubed. So we'll cross multiply here. We get x equals, and then what we have to do is multiply these two. 1.036 times 1.0936. This turns out to be 113.29696 yards cubed. Okay, now it doesn't say where to round it off to. I would say to be safe, write what you have in your calculator. Otherwise, usually 1 decimal is good. So we'll say 113.3 cubic yards you should order. Okay, next one. Placing cups into a 7-inch by 10-inch tray. So it's 7 by 10 inches. Each cup has a circumference of 10 inches. So the circumference is 10 inches. Determine the maximum number of cups you can place on the tray. Show your work. Well, I guess what we need to do is we need to figure out what's the diameter. Okay, and if you look in your formula sheet, the circumference is pi times the diameter. So if we know the circumference is 10, we know what pi is, we can figure out what the diameter is. The diameter is going to be 10 divided by pi. So if I go 10 divided by pi, turns out the diameter is 3.183 inches. Okay, so I mean this is not going to be to scale here, but you could see that you would be able to put 2 there, but it wouldn't have enough to fit the third one there because this is 3, this is 3, that's going to be already over 6. Okay, and then if we think about going this way, how many would be able to fit here? Well, would you be able to get 3 times? Yeah, it looks like you could do it 3 times. 3 times 3 is 9 something, not quite 10 yet. So it looks like you'd be able to put 6 cups on the tray. Now this is assuming that we're not going to try to, I guess, you know, it's possible to figure something out that's a little bit more difficult. We could try to do something, you know, if we put one in this corner and one in this corner, maybe this one would fit in there a little bit, and maybe we would end up getting a few more cups in there. We don't know this for sure. It's a little bit more work than we have to do here, so we're not going to do that. What I would do is I would say, here's my work. This is showing that I can fit 6 cups. Okay? Next one. The tank consists of a cylindrical section with a hemisphere at each end. Find the surface area of this tank. Okay? So if we change the shape, just for the purposes of this question, if you took the 2 sphere pieces at the end, this would make a full sphere. Okay, so if I wanted to find the surface area, I'm going to find the surface area of the sphere plus the surface area of a cylinder. Okay, the surface area of a sphere is 4/3 pi r cubed. The surface area of the cylinder is pi, oh sure, that's volume, my mistake. That's pi 4 pi r squared. And this is 2 pi r h plus 2 pi r squared. Okay, now just to be clear, I am not going to count those. What are those? Well, they're the ends of the cylinder. This and this, which you can see will be covered up in this case. Okay, so I'm not going to include those in my formula. They're the overlap. So I'm just going to have 4 pi 1.1 squared. Hey, where did I get 1.1 from? It's half of 2.2. Okay, it's just the radius. So then 2 pi 1.1, and then the height is 6. So let's put this in the calculator. You might want to get used to being able to put this all in the calculator at once without writing stuff down. Takes a little bit of practice. Okay, and this is feet squared. Let's do the volume of the tank then. So the volume will be the volume of the sphere plus volume of the cylinder. And remember, with with volume, you don't have to worry about overlap. So this is just 4/3 pi r cubed plus 2 pi r, sorry, getting ahead of myself. It's pi r squared h. So 4/3 pi, and what is r? 1.1 cubed plus pi times 1.1 squared times 6. Okay, so I just rounded it off there to 0.4. Alright, one more example. Given the following pyramid with dimensions as shown, calculate the surface area of material to make the pyramid, including the base. Okay, remember I told you when you're doing surface area, the best way to do this is to look at all the faces. Now it's a square, so I'm going to add the base, and I'm going to have 4 of these. I'm going to have 4 triangles that have a base of 6, but what is their slant height? Okay, this 4 here tells me that I have the height from here to here. So if you remember this from grade 10, we have to make a triangle to figure out what the slant height is. Okay, I know this is 4, and I know this is 3, which is halfway across the base. And if I use Pythagoras, this turns out to be a 5. Okay, so we'll write it as a height of that triangle is 5. So how do I find the area? Area of a triangle is base times the height divided by 2. And remember, we have 4 of those. Plus, I'm going to have 6 times 6. Okay, so this is 60 plus 36 is 96 meters squared. Okay, now we're going to turn this pyramid over. The pyramid is to act as a tank. Calculate the volume in cubic centimeters. Okay, so volume of a pyramid is the base, the area of the base. Okay, and we use a capital B for that, times the height divided by 3. Now the area of the base was 36. The height, that's 4. Okay, remember it was from here to here was 4, divided by 3. So this is 48 meters cubed. Okay, we're supposed to figure out how many liters that is. So the first thing we need to do is convert 48 cubic meters to cubic centimeters. Well, you know that 1 cubic meter is 1,000,000 cubic centimeters. So that means we have 48 million centimeters cubed. Okay, and now we have another ratio that we're supposed to figure out. We know that 1 liter is 1,000 centimeters cubed, and we have 48 million. So we have to figure out what x is. So cross multiply, we get 1,000x is 48 million. And so X is 48,000 liters. All right, that's the end of lesson 2. So I'm going to give you assignment 2. You can do numbers 1, 2, 3, and 4. Skip number 5 and then number 6. Number 6 is a pretty complex question. Okay.